Hello and welcome. In this video, we will look at the Remote I/O interface, which is a new product in the HIL interface product line from the 2023.2 release of Typhoon HIL Control Center. The Remote I/O interface is made up of two components: the Remote I/O device hardware and its complementary schematic editor component called Remote I/O Interface Ethernet. The Remote I/O device is an I/O expansion device intended to supplement HIL setups. By using the Remote I/O device, you can expand your interfacing capabilities beyond the HIL device's built-in I/Os. It has the same dimensions as a HIL 6 series device, making it an easy addition for large setups where I/Os make up the bottleneck. Multiple Remote I/O devices can be connected to the same HIL device, allowing you to increase the number of I/O channels even further. Data exchange between the Remote I/O device and the HIL device is managed by Ethernet variable exchange. Device inputs are sampled and outputs are updated with a rate of up to 1 millisecond. This makes it suitable for setups involving average analog signals, such as RMS voltage and current measurements, slow dynamic signals such as temperature measurements, and digital signals such as indication signals. We can see that the Remote I/O device has retained the same familiar casing design as our HIL 604 and HIL 606 devices. Let's take a closer look at the device. On the front plate, we see two rows of connectors. It is important to note that these two rows are independent from one another, as the Remote I/O device is comprised of two independent Remote I/O cards. Each card has 32 analog and 32 digital outputs, as well as 32 digital and 16 analog inputs. Let's see the back of the device. On the back plate, we can see two standard Ethernet ports. Next to them are two micro SD sockets, with each one belonging to a single Remote I/O device card. Finally, we see two pairs of rotary switches, with each pair belonging to a single Remote I/O device card. The Remote I/O device cards are labeled as Device ID 1 and Device ID 2. Remote I/O Interface Ethernet is a complementary component to the Remote I/O device, which serves as an interface between the Remote I/O device and the simulated model. It can be used to send different signals to the appropriate outputs of Remote I/O device and observe the appropriate inputs from the device. It is a part of the new HIL interface component library. The component handles Ethernet variable exchange setup, making the whole system easily configurable. We will discuss the component and its properties in more detail later in the video. Here, we have an example of a CHIL setup where the plant is made up of a battery pack containing 12 battery cells in series, along with the charger. The controller in the HIL system is a battery management system. The controller receives cell voltage, cell temperature, and internal resistance measurements, among other data, from the simulation through its SIOS. In turn, the BMS provides balancing current references to each individual cell, references for the charger, as well as numerous digital signals, such as indication signals related to the charger. Let's see how the whole setup is physically devised. First, we have the PC connected to the HIL 606 device via USB. The necessary networking hardware is realized using an Ethernet switch, to which both the HIL device and the Remote I/O device are connected via standard Ethernet cables. The Remote I/O device is then connected to the HIL Connect via their respective DIN connectors. Finally, the HIL Connect is connected to the BMS, thus completing the setup. Now that we have seen the setup, let's look at the Remote I/O Interface Ethernet component in more depth. We can see that there are 8 ports available on the component. These ports are divided into 2 groups, where each group corresponds to a single card inside of the Remote I/O device. A single group consists of 1 pair of analog and digital inputs, as well as 1 pair of analog and digital outputs. The input ports on the left side are used to source values from the simulation to the analog and/or digital outputs of the Remote I/O device, while the output ports on its right side serve to source signals received on its inputs into the simulation. It must be noted that all signals fed into and out of the component are in vector format, where each element of the vector corresponds to 1 pin of the remote device. Now, let us open the properties of the component. First, we have the HIL device ID. This parameter should match the HIL device setting to which the Remote I/O device is connected and should be used in multi-HIL simulations. If only one HIL is used, This option should be left on the dash marker. Next, we have the Include Ethernet Setup checkbox. Let's let the component handle Ethernet Variable Exchange Setup by checking this option. Alternatively, Ethernet Variable Exchange Setup can be done manually using the Ethernet Variable Exchange Setup component from the library. The device ID 1 and 2 properties should match the position of rotary switches labeled as 2 in their corresponding device ID groups on the remote I/O device. Finally, we have the sample time, which is the message sending rate, as well as the execution rate of the component. Now, we will compile and run the model and observe some of the signals exchanged between the simulation and the controller. As you can see here, we have opened both the simulation running in HIL SCADA and the proprietary BMS software that will interact with the model. First, let's compare the cell voltage measurements in the simulation, which are provided on the analog outputs of the remote I/O device, to the ones received by the BMS. Next, we can see that the battery pack is currently discharging. The BMS is the one providing the charge and discharge current limits to the analog inputs of the remote I/O. One example of a digital signal sent from the simulation to the BMS is the disconnected cell fault, which indicates to the BMS that a particular cell is disconnected. Let us disconnect the cell and show the BMS response. Finally, we can check out some indication signals provided by the BMS to our remote I/O digital inputs. In this tutorial, we have presented the remote I/O device and showed how, from the 2023.2 Typhoon HIL software release, you can use the remote I/O interface Ethernet component and the remote I/O interface device to expand the I/O capacity of your HIL devices. Thank you for watching.
Check the video description for more resources on this topic, including how to download and get started with Typhoon HIL Control Center for free. You can also visit HIL Academy to access free courses, expand your HIL testing skill set, and get certified. Subscribe to our channel to get notified about new content.